What were the major design flaws of the RBMK reactor used at Chernobyl? Have you ever wondered what went wrong with the reactor at Chernobyl? The RBMK reactor had several design flaws that played a major role in the disaster of 1986. Understanding these flaws is essential, especially when we think about high-risk professions like nuclear power plant operation. One of the most critical issues was the positive void coefficient. This means that if the coolant, which is water, turned into steam, it created bubbles in the coolant system. In many other reactors, this would reduce reactivity. However, in the RBMK design, it caused an increase in reactivity. The graphite moderator continued to moderate neutrons, while the loss of coolant reduced neutron absorption. This led to an exponential increase in neutron production, which could result in a runaway reaction. Another significant flaw was the lack of a containment structure. Many Western reactors have a full containment structure to prevent radioactive materials from escaping. The RBMK reactors at Chernobyl did not have this safety feature. When the accident occurred, radioactive materials were released into the environment, causing widespread contamination. The design of the control rods also had serious problems. These rods are used to regulate the reaction by absorbing neutrons. However, the tips of the control rods were made of graphite. When these rods were inserted into the reactor, they initially increased reactivity. This flaw could lead to a rapid increase in power during emergency shutdowns, making the situation even more dangerous. Additionally, the RBMK reactors were unstable when operating at low power levels. This instability, combined with the positive void coefficient and control rod design issues, made the reactors difficult to control safely. Inadequately trained personnel further complicated the situation, leading to poor decision-making during critical moments. These design flaws reminded us of the importance of safety measures and proper training in high-risk professions. Just as storm chasers must be ready for unpredictable weather, nuclear operators need to be trained to handle their equipment's unique challenges. The lessons learned from the Chernobyl disaster highlight the need for robust safety protocols and continuous improvement in reactor design to prevent similar accidents in the future.